Folks, welcome back to BFI 12 and network optimization. So this topic is about the maximal flow problem. So if you recall, so I was talking about, the application areas for this, and one would be what is the maximum that we can take out through a system of, network. Here in this case, let's say that we got a hotel here and the Disneyland. Okay, so there are guests who are staying in the hotel here, and there are several different ways of getting to the Disneyland. And this is the, the system, the road network system that I have. What it says is, in this direction about 10 cars can go from 1 to 2, and it's a bidirectional road. 2 cars can come from 2 to 1 per given unit of time, okay, per given unit of time. Maybe this could be on a 10-minute basis, 5-minute basis, whatever the unit of time is. For example, 2 to 6 is a one-way road. Only 3 cars per unit time can head from 2 to 6, and none can come back this way. And likewise, so here I have the limitations on each one of these roads, and some are bidirectional, some are just unidirectional. So the problem here is, what is the maximum number of cars that can be sent out from 1 to 11, so that we want to maximize the number of cars that go from 1 to 11 using this network of roads. Okay, we want to maximize the flow from 1 to 11. The way that I have laid out here is, so this is road work that we have. I have an arc. This is an artificial arc that's going from 11 to 1. Okay, it's an artificial arc. It's not given in the problem. So by sending this maximum number out from here 1 to 11 is same as going to 11 and trying to pull out the maximum number out of this system, pulling it out. So that is same as pushing maximum through the system. So here I have an arc going from 11 to 1, and that what you see there, 11 to 1. So the reference here that I have drawn to is, let me try to pull as many cars as possible out of this system going from 11 to 1. Actually, they are not going from 11 to 1. What we want is maximum that go from 1 to 11 is maximum that comes out of 11 onto nowhere. Okay, so that's what I'm trying to do here. I just give that reference to that cell. So as before, what we have is, we have from 2, and then the shape, the maximum number that can go from there to here, and the capacity. Like for example, here I have 1. If you look at that, the direction is 1 to 2, 1 to 3, 1 to 4, 1 to 5. Okay, so that's what I have here, 1 to 2, 1 to 5, 1 to 3, 1 to 4. Then I have from 2 to 4. So 2 to 1, because it's a bidirectional, and 2 to 4, only one directional. Then I go to node 3, then look at all the combinations. 3 to 7 is there, and 3 to 1 is there. So that's what you see here. Likewise, I go to 4 and get those pathways. Okay, get those pathways. And get those things here. So from, and that is where it is going to go to. And the capacity is 10. And coming back is 2, so that's what you see here. 1 to 2 is 10, and 2 to 1 is 2. So get all those information into the network here. So from 11 to 1, we don't have any capacity on this. Just choose a number that's bigger than any number that you see, the sum of numbers that you see here. I have 10 here, 8 here, and 15, and all those things. I don't know what's the maximum that's going to go through, because we are interested in pulling the maximum out. But if you keep this limit as 10, so possibly there could be more that can be pulled out, but by putting that artificial number like 10, you are restricting it to 10. So just go and choose a big number like 1000, and we know that there are, even when you add all these numbers together, it's not going to sum to 1000. So you don't want to restrict the amount that's coming out. You want to find out what's the maximum that's coming out. So that's why I choose a bigger number here. Okay. So here from 2, and just like before, I have named the ranges. Like for example, the from is that range. Okay, so select the range, then go type the name that you want to type for that. So here I have a set of ranges from, that's there, 2, and then the node, then I have the capacity, okay, capacity, those things. And here is the net flow. Net flow is the SUMIF command, SUMIF from, go to the from list, and then which one are we looking at? The node is H6, that is node 1, and the amount that is being sent from node 1, so just go choose all those and sum them up, and minus SUMIF, that is now next is go to the 2 column and look at all those that are ones in that column, here, likewise. Go look into that list and go to the corresponding cells that is in the shift, then add them up. So going out minus coming in, so that is the net sum, okay, net sum. So that's the net flow, and then copy the command down to all the nodes. Okay, now when you go and then when you click it here, so from and shape, they remain the same. See, that's one advantage of naming the ranges is the reference when you copy that becomes absolute. So still when it chooses from and to, just like the way that it did here, it takes the entire range. Now the node that was referenced here, when I copy the formula down, it becomes a relative reference. It is not picking there up, it is picking the next node, that is node number 2. Okay, so that's where I have H7 there. When I copy and paste, double click and see whether it is picking up the required information. So once you have that, the net requirements is, what we are trying to do is, we are trying to, it's a closed system. So it's a closed system. So whatever that's being sent out is being pulled back into that. So in other words, nothing is escaping this system that we have. Remember that I got this artificial arc here. So what that says is whatever that's flowing through the system is still flowing through the system. So the net that is coming out, that is escaping this boundaries that we have, including the artificial boundary, is 0. Okay, so that's what that requirement is. 0 is whatever that comes in is going out. Okay, so that is the net flow should be equal to 0. Should be equal to 0. Maximal flow, what we want is, let's pull as much as possible from this system from 11 to 1. So that's that reference that I have there for D34. So go there and data, solver, so what we have is maximize this cell, maximize that cell. The changing cell is a ship, okay, which is nothing but this range. So as I said before, you can either go, you can type in the name, or you can go select the range as we did in the earlier problem. So here I have typed in the name. Okay, then add the constraint, the ship, because remember I have named this range ship. Ship is less than or equal to capacity. So that's when is basically when you do it here. Okay, that's where you are going to do it. Okay, let me do one thing. Let me just erase these things. Then type it here. So this is the ship. Okay. Then I'm just going to delete that, and I'm going to delete that. Now add the constraint. The constraint is the ship is less than or equal to the capacity. You can type that capacity. Okay. Then add the constraint. That constraint is my net flow. My net flow equals the requirement. Suppose if I had named this range as net flow, I could just go type in the net flow. I did not name this range. And likewise, if I had named this range as requirements, I could just go and then type in the requirements. Since I didn't do that, I had to go and then I have to select. So these are different ways that you can do it. Okay. So now we got all the constraints. So that is shipping should be less than equal to capacity, and the net flow should balance. So we have that. Then options. Linear, non-negative, click on those. Okay, then solve. So when you solve, solver found a solution. All constraints optimality conditions satisfied. Click OK. What it tells you is from a system of network, I mean this network that we have, the roads, some are bidirectional, some are unidirectional. With those capacities, the maximum number of cars that you can send from one to Disneyland, although you have a capacity on the road of 10 plus 8, 18 plus 8, 26 plus 15, which is 41, you can send out 41 cars from hotel to the Disneyland. The maximum that you can send is only 13. Okay, that is because of the capacity on the roads that exist, and some of them are bidirectional and some of them are unidirectional. So there are some cars that are flowing in the opposite directions, restricting the capacity. Now this is a kind of a solution that you would address in a real life application where so this could be the stadium, and this could be a point that is away from the stadium that you want everyone, basically users, to exit out, and this is a system of a network of roads that you have, and you can go back and then you can change the capacity on the roads by making them unidirectional, bidirectional, to attain what's the maximum number that you can send per unit of time. So this is a maximal flow problem.